Hi everybody, this is a quick video to show you how to run a Factorial ANOVA in JASP and read the output. So I've opened up JASP and I'm going to go to Recent Files, Factorial ANOVA. And this is just a data set that I made up, looking at self-esteem as the dependent variable, birth order as a 3-category independent variable, and gender as a 2-category independent variable. So I go to ANOVA and I just click on that. Self-esteem is my dependent, birth order and gender are my 2 independent variables. It's handy to get descriptive statistics and estimates of effect size. So let's stop here for a minute and take a look. Okay, so I've got my Factorial ANOVA results, and I have 2 possible main effects, one for birth order, one for gender, and 1 possible interaction effect. So I look at my birth order main effect, and I see that it is statistically significant, and it's got an eta squared of 0.167. So I would say there is a statistically significant difference in the means of first, second, and third born children on self-esteem when controlling for gender and birth order by gender interaction. The difference between the sample means did not occur by chance. Therefore, I know there's a difference in the population means of first, second, and third born children on self-esteem, but I don't know where that difference is yet. In addition, I know that 16.7% of the variance in self-esteem is explained by birth order. Next, I look at the main effect for gender. I see it is not statistically significant, has a tiny effect size, and I say that when controlling for birth order and the interaction of birth order and gender, there is no significant difference between males and females in self-esteem. Finally, I see I look at birth order by gender interaction. I see that that is statistically significant, and that's got a quite large effect size. 34.7% of the variance in self-esteem is explained by this birth order by gender interaction. And what this interaction tells me is that the differences between first, second, and third born children in self-esteem depends on their gender. That is statistically significant when controlling for the main effects of gender and birth order. Okay, so that's how you talk about this part. Then if I look down here, I can start to get a sense of where these differences might be. So what I can see is that among firstborn children, there's not much difference between male and female. Among secondborn, females have higher self-esteem than males, and among thirdborn, that trend is reversed. Males have higher self-esteem than females among thirdborns. So I can start to see where this interaction is happening. The pattern of differences between males and females depends on whether they're first, second, or third born. And the pattern of differences between first, second, and third born kids on self-esteem depends on whether they're male or female. Now, I can go deeper in this analysis and look at some other stuff. So, we found that there is a main effect for birth order, meaning first, second, and third born kids on average differ in their self-esteem. That is when you combine the 2 genders together. And when you do that, we decided that there's a difference in the population means, but we're not sure where those differences are. So if we do a post hoc, we can see that firstborns have higher self-esteem than secondborns, and that's significant. Firstborns also have higher self-esteem than thirdborns, and that's significant. Secondborns have lower self-esteem than thirdborns, but that's not significant. So we would say that when controlling for gender and the interaction effect, firstborn kids have higher self-esteem on average in the population than second and third born kids. But there's no difference between second and third born kids. Okay. One thing that can be a little bit confusing is that we don't actually know the means of first, second, and third born kids when we put the two genders together. And to find those means, what we look at is marginal means. So if we look at the marginal means for birth order, now we can see, oh, okay, I see this. Firstborns have higher self-esteem than second and thirdborns. There's no difference between second and thirdborns. I can also look at the marginal means for gender, because remember we found up here that there was not a significant difference between males and females. So when we're looking at the means for males and females, that is combining across first, second, and third born kids, we see males and females are quite similar, and it's not a statistically significant difference. All right. Last thing I'm going to show you is simple main effects. So you might be wondering something like, okay, I know, let's see, these two means of males and females in the firstborn group, they look pretty similar. And then there's a little bigger difference between the males in the firstborn group and the females in the secondborn group. I wonder if that's significantly different. I wonder if the difference within the secondborns, that gender difference, I wonder if that's significant. And these things are known as simple effects when you're just comparing sort of one cell to another cell. So if we click on simple effects and we put one of the variables as the simple effect factor and the other is the moderator factor, here's what you get. Simple main effects. So what we see here is that males, just looking at males, across the three birth order groups are significantly different from each other. And females across the three groups are also significantly different from each other. So just looking at females across the three birth order groups, we can see that there's differences between those means. Let's switch these around. Whoops. Let's switch these around so you can see that what it looks like in a little bit different way. Okay, if I flip those around, now I get this. Among firstborn kids, is there a gender difference? Do the males and females in that firstborn group differ? No. Do the males and females in the secondborn group differ? Yes. Do the males and females in the thirdborn group differ? Yes. So these are some of the things that you can look at with Factorial ANOVA in JASP. If you really want to get deep into the individual group differences, you can do a post hoc on the interaction, which is kind of interesting. If you do a post hoc test on the interaction, this is what you get. You get each cell compared to each other cell, and you can find which specific groups differ from each other. So second-born males are significantly different from third-born males. They're also different from first-born females. So you can look there for each cell compared to each other cell. All right, that's enough. Gets a little deep, but that's how you run and interpret Factorial ANOVA output in JASP.